In this video, we will discuss about the image formation by concave mirror. Let us first discuss how many cases are available for which an object can be placed in front of concave mirror. So this is my mirror. This is your pole, center of aperture pole, center of curvature C, and the focus, principal focus, midpoint of C and P. Now, the first case is when the object is very much far away from the mirror. This is a mirror when you place your object very far away. So I am taking the first case when the object is at infinity. Now bring your object more closer to the mirror, but still it is away from C. So it is our second case when the object is away from C. Now bring more closer, that is here when the object is at center. This is our third case when object is at center. Now bring it more closer. Now it becomes between C and F. So this is our fourth case. Now bring the object more closer to the mirror. Now it is at focus. So when object is at focus, this is the fifth case. Now bring this object more closer to the mirror. Then it is between F and P. This is our sixth case. So here there are 6 cases where we can keep our object in front of concave mirror. Let us discuss one by one. Let us discuss the first case when the object is at infinity. So when an object is at infinity, then the parallel rays of lines are coming from an object. So I will draw the two parallel lines. The two parallel lines are in such a way that they follow the rules which we have studied. The first ray is that when any ray which passes through center. So I make it any ray which passes through center. So this is the first incident ray which is passing through center. We know that any ray which passes through center will retrace its path. It comes back along the same path. Now the second ray, as the object is at infinity, so the parallel lines. So I will draw the parallel lines which is passing from principal focus. So this is here this much. This is our second incident ray. So any ray which is passing through the principal focus will become parallel to the principal axis. So it will become parallel to the principal axis. So this is your parallel to the principal axis. So these two are the incident ray. This is incident ray and this is your reflected ray. This is the incident ray and comes back into the same. This is your reflected ray. Where the two reflected ray, this is first one reflected ray, this is your second one reflected ray, where they will meet, that is your image. So they are meeting at this point. So we'll draw the image. So you see here the image is at focus. So this is your image A dash B dash. So what do you conclude from here? When your object is at infinity, your image is at focus. Now what is its nature? From here you can see that the rays are actually meeting after reflection. So this is a mirror and the rays are actually meeting, so that is why its nature is real, and all the real images are inverted, so it is a real and inverted. What is its size? Size is highly diminished. If you see here, when this object is very far away, so it is very far away, it is of more than this size, and a very far away object, and the image is this much small, so it is highly diminished. So this is when your object is at infinity. Discuss the first case when the object is at infinity. When the object is at infinity means parallel rays of line coming from the object. So here it is my concave mirror, principal focus, C is the center of curvature, any ray passing from center and pole is known as the principal axis. Principal focus is a midpoint of C and P. As the two parallel rays are coming from the infinite object, then I draw the two parallel lines. First ray is passes through center. Any ray which passes through center will trace back. And second ray passes through principal focus. Any ray passes through principal focus will become parallel to the principal axis. These two reflected rays are meeting at this point and it forms an image. Here the image is formed at principal focus. So this is your image. Here, when you place your object is at infinity, whenever your object is at infinity, your image will always be formed at principal focus. And since the rays are actually meeting, after this reflection, they are actually meeting at this point, so it is a real and inverted. And what is the size? Size is highly diminished because size is too small. Far away object is bigger in size and the image will be very, very small. Now let us discuss the second case when an object is away from the center. Mean it is not at infinity but it is away from C. So here I am placing my object here. This is my object O at this place. Now to form an image, I will make or I will draw minimum two rays and those rays whose rule is known to me. So first ray, I will draw any ray which is parallel to the principal axis. So here I am drawing a parallel ray, any ray which is parallel. So this is your a parallel ray, any ray which is parallel will passes through principal focus. So this is your reflected ray. Second ray, any ray passes through center or passes through principal focus. That will also meet. So any ray which passes through center will retrace its path, comes back into the same path from where it has come. So where these two reflected, here this is the first one reflected, this is the second one, where they are meeting at this point. So this is your image. Vertical line from here, it is an image. So this is your image I. So you can see there when your object is at or it is away from center of curvature. When your object is away from the center, your image is between C and F. Image is between C and F. Now here the rays are actually meeting. These rays after this mirror, the rays after the reflection of this mirror actually meeting at this point. Then this nature of this mirror is real. So real images are always inverted. From here you can see that here arrow is upward and the image arrow is downward. So it is inverted. Next is what is the size of image. So from here you can see that here object is little bit bigger than as compared to the size of image. So you can say that here image is diminished. So again, when your object is away from center, your image is between C and F and it is real inverted and it is small in size. Now let us discuss the third case when object is at center of curvature, that is C. Here this is my concave mirror, this is your center of aperture is pole. Any ray parallel or it is passing from center and P is known as a principal axis. The midpoint of C and P is known as a principal focus. Now my object is at center, so I draw a object at center. This is my object O. Now I will draw the two rays whose rule is known to me. So first rule is any ray which is parallel to principal axis. So I'll draw a ray parallel to principal axis. our incident ray, and the reflected ray will be passing through principal focus. So this is our reflected ray. Second ray, I will make it to pass through principal focus. Any ray which is passing through principal focus will become parallel to the principal axis. So it will become parallel to this principal axis. So this is your reflected ray, and the image is where the two reflected ray meet, that is your image. So they are meeting at this point. If you draw a vertical line from here, see here, it is passes through center. So this is my image. So here you can see that when your object is at center, your image is also at center. See here, image is also at center. And what is its nature? Nature of the image, since the rays falling on the mirror and get reflected and meeting, so no rays passes or crossing this mirror, or so we can say that the nature of the image is real. The real images are always inverted. From the diagram also you can see here, the object is upward, the image is arrow is downward. So it get reversed. It was upward, the images get inverted, up and down. So it is inverted. So what is its size? So from here you can see the length of this one. You see that length is equal. See the length is equal. So it is of same size. So again, when your object is at center, your image will also be at center, and it is real, inverted, and it is of same size. Now let us discuss the fourth case. Object is between center and focus. So here it is my concave mirror. The center point is known as a pole. C is a center, where if I keep a compass, it can curve out this arc. A ray passing from center and pole is known as a principal axis. So this is our principal axis. The midpoint of C and P is known as principal focus. Now in fourth case, object is between center and focus. So anywhere I draw, this is my object. So this is your object O, which is between center and focus. I can keep it anywhere between C and F. So I will draw the two rays, minimum two rays, to form an image, and those rays whose rule is known to me, or I know the rules. The first ray is parallel. Any ray which is parallel will pass through principal focus. So this is our reflected ray. Second, any ray passes through principal focus. Any ray which is through principal focus will become parallel to the principal axis. So it will become parallel to this principal axis. So this is our reflected ray. So this is our first one incident ray, this is your first one reflected ray, this is your second incident ray, and this is your second reflected ray. Where they will meet, they are meeting at this point, and there, that is the image. So I draw a vertical line from the principal axis, and it is an image. So this is our image I. So from here you can see that your image is away from C, from the mirror. If you are sitting at a mirror P point, then the image is away from C. So you can see the object is between center and focus, then your image is away from C, and their rays are actually meeting, because after reflection they are actually meeting at this point, so it is a real and inverted. And if you see the size, here it is, object size is smaller as compared to the image, so here the image is enlarged, having more size. So you can see right here, when your object is between center and focus, your image, first one is away from center. What is nature? The nature of the image is real, because rays are actually meeting at, after this reflection they are actually meeting at this point, so that is why it is a real image, and real image is inverted. From the, also you can see that here this arrow is upward, and here in the image arrow is downward, so it is downward, so it is inverted. What is size? The size, you can see the size is enlarged, the image become bigger than that of the object. So here it is, fourth case, when you place your object between center and focus, your image is away from C, real inverted and enlarged. Now let us discuss the fifth case, and an object is at principal focus. So it is our concave mirror, and center point of the mirror is known as a pole, and a ray passing from pole to center. I draw here horizontal line. So this is your principal axis. C is a center. If you keep a compass, it can curve out this arc. And principal focus is a midpoint of C and P. This is a C, this is your P, and it is midpoint 3.5. So here, this is your principal focus. If I keep this F is a midpoint of C and P, our all ray diagrams will be correct. So here, in case fifth, my object is at principal focus, so I draw a vertical line. So this is an object, so I will draw minimum two lines, your two rays, whose rule is known to us, here me. So first ray, I will make it to pass through, it is going along the center. So any ray which is going along the center or in the direction of center, it is looking like it is appear to pass through center. Any ray which is passing through center will trace its path, so it will go back into the same path from where it has come. So this is our incident ray and get reflected back. Second ray, I cannot pass through the principal focus, so I make it to fall at P, for P, making some angle I, that is angle of incidence. According to the law of reflection, angle of incidence is equal to angle of reflection. The same angle it will make, same angle of reflection it will make. So I make it here. So I draw, this is your reflected ray. If you see these two reflected ray, they are the parallel lines. So these parallel lines, they never meet at any point. So I suppose they are meeting at infinity. As in the first case we discussed, the parallel rays are coming from infinity. So their parallel rays are going, this means they must be meeting at infinity. So what we discussed, when your object is at focus, your image is at infinity. What should be the nature? So they are meeting at this, in this region, meeting in this region. After reflection they are meeting, so it means the nature is real. So real image is inverted. And what is the size? Size is enlarged, highly enlarged. So this is our fifth case, when your object is at focus. When your object is at focus, your image is at infinity, images are real, inverted and highly enlarged. Case sixth, when your object is between principal focus and pole. So this is our concave mirror. Center point of this is known as a pole. C is a center, which if you keep a compass over here, it can curve out this arc. An array or a line passes from center and pole is known as principal axis. This is your principal axis. extended in both directions. Now the midpoint of C and P is known as a principal focus. So this is your midpoint, principal focus. Now I am placing my object between focus and pole, so I can keep anywhere between F and P. This is my object. So to draw an image of an object, I will draw minimum two rays. The first ray is that which is appear to pass through center, or it is along the center. So any ray which is passes through center will trace its path, it will come to back. So this is our reflected ray. So this is our reflected ray. Now second ray is, I will make it to pass on the principal focus. Any ray which is making some angle of incidence I, then the reflected ray will also make this equal angle of incidence, angle. So the reflected ray will also make equal angle of reflection. So that is angle of reflection. So I'll draw the reflected ray along this direction. So this is our second reflected ray. If you proceed these two rays, they are not going to meet anywhere if you proceed them in a forward direction. So we are proceeding them in a backward direction. So they are meeting at this point. So this is our image. So when your object is between principal focus and pole, your image is behind the mirror. The mirror is this much, this is the front portion of the mirror, and it falls behind the mirror, as in the case of plane mirror. The nature of the image is real. Disturbance create. So the nature of image is virtual. See here the rays after falling get reflected back. The rays cannot cross this mirror. The rays from the object, going from the object, falls on the mirror and comes back. Here the no ray has crossed this mirror, but it appears to us that they are coming, these two reflected rays are supposed to be coming from this point, but actually the rays has not crossed this mirror. So that is why the nature of the image is virtual, and virtual image is erect. From here you can see that here the arrow is upward, here also arrow is upward. So it is erect image. And what is its size? Size, you can see here the object size is small and image is bigger. So it is magnified or enlarged. So this is your the last case, when your object is between focus and pole. Your image is behind a mirror, it is virtual and erect, and it is enlarged. So this is your the image formation for the case of concave mirror. Let us summarize all the result in one diagram so that we can remember the image formed, the location of image formed when you place your object at different position, and what is their nature and what is their size. Let us talk about first position. When you place your object at infinity, your image is at focus. Next one, fifth case, when object is at focus, here your image is formed at infinity. So from here you can see that if you rewind the video, you will find that when your object is at focus, your image is at infinity. If your object is at infinity, your image is at focus. So next one is, if your object is away from center, away from C, when your object is away from C here, then your image is between C and F. Here, when your object is here, when your object is between C and F, then your image is away from C. From here also you can see that when you place your object here, that is away from center, your image is between C and F. Between C and F. If your object is between C and F, then your image is away from C. Or reverse order. If you place your object away from center, then your image will be between center and focus. If your object is between center and focus, your image will be away from center. And the rest case is when your object is at a center. When your object is at C, your image will also be at C. If you place your object at C, your image will also be at C. And the last one case is when your object is between focus and pole. Here, object is between focus and pole. Your image is formed behind the mirror. Means this side. So this is your different location. When your object is at infinity, your image is at focus. If your object is at focus, your image is at infinity. So they are interconvertible. So these are interconvertible. Similarly, when your object is away from C, your image is between C and F. Here. If your object is here, your image is here. So these both are interconvertible. They exchange their positions. And the two cases, when your object is at center, image is also at center. And the last one, when your object is between focus and pole, your image is behind a mirror in this side. So this is the different location of the object at different cases. Now let us talk about in terms of nature and size. This is our concave mirror. This is your center and this is your principal focus. Now here I will tell in terms of nature, and here I will tell in terms of size. Now in terms of nature, the focus is a turning point. If you place your object anywhere in this region, infinity to focus, then if you place your object here in this region, your image will always be real, and real image is always inverted. Again, if your object is in this region from infinity to this focus, from anywhere you place your object, your image will always be real, and real image is always inverted. And the rest one case, if your object is between focus and pole, if your object is in this region, then the image will be virtual, and virtual image is always erect. So this is the turning point. Focus is a turning point for the real and virtual image. It tells you about the nature of the image. Now let us talk about the size. Here C at say is a turning point. If you place your object in this region, object is in this region, means object is infinity to away from C. In this region, then the image will be always small in size. Then the image will be small in size. If your object is from C to P anywhere, object is in this region, then the image will always be enlarged. It is having large size. Anywhere you place your object in this region, then the image is enlarged. So further, we able to understand where your object forms a real image and virtual image, and where it forms a small image and enlarged image. So this is your all about. Thanking you.